Hello and welcome to tribetopper.com.
This video on important concepts of electrostatics for grade 12. So in this video we are going to discuss about electric field lines. See, the imaginary lines, the definition is simply that the imaginary lines which represent the direction of force of interaction between two charges are called the electric lines of force or electric field lines. This is just a definition for for the sake of writing a definition. That's, we have some imaginary lines and we call them as the electric field lines. So as we know that the direction, because we know one thing, that if I have a unit charge Q placed here and or any test charge, and I have another observation charge, we have defined that this charge is going to exert a force of attraction or repulsion on this charge Q naught, which we are going to observe. So this is the test charge and this is the source charge. Source charge is the one which produces the field and test charge is the one which experiences that field or the force. So we know that this charge Q is going to exert a force on this charge. The direction of this force can be represented by the imaginary lines. So those imaginary lines are known as the electric field lines or the electric lines of force. Now, one thing important about electric field lines that you really need to understand is that if you have a positive charge, so if my source charge is positive right here, then the direction of the electric field lines is going to be acting outwards away from the charge, as you can see with the arrows marked. So they will be going out like this. And if I have a negative charge Q, then these same electric field lines would be lines pointing towards the charge. So the arrow would be indicating the direction is towards the charge. So in case of positive charge, the electric field lines diverge out or they originate from there, and in case of negative charge, the lines of force, they end up at the negative charge. Now there are some important properties of this electric field line. So let's note down those properties. So the first important property about electric field lines is that the electric field lines give the direction of the electric field. So as you can see here that the arrows indicate the direction of the field. So they are all originating from this positive charge and they're going out. So every time the direction of force is indicated by the direction of the electric field, which in turn is given by these imaginary lines called the electric field lines. So the first property is that they give the direction of the electric field. The next one is very important property, that the number of field lines, they give us the strength of the electric field at a point. Now you can see here that the field lines, they are crowded near the charge. So near the charge in a certain area you have lots and lots of electric field lines. As you go farther away in that same area, you may be left out with just half or 1/4 of the number of lines. So that means as you keep on moving away and away from the charge, the number of field lines, they move farther and farther. So the crowding of the lines near the charge indicate a strong electric field nearest to the charge. Thus we can say that the number of field lines, it actually gives us the strength of the field at that point. And this completes the definition also, that the imaginary lines which give the direction of electric field and the strength of electric field at a point are known as the electric field lines. Let's go to the third property. Another very important property is that no two electric field lines can cross each other. So as you can see here, the electric field lines, they will never intersect each other. Like you cannot have an electric field line going this way and another one going this way, like at the crossing. Because why this is so, this is like sometimes asked as a 1-mark question, why no two electric field lines can cross each other? It is because at the point of intersection you will have two directions of the electric field at the same time, which is impossible. So we can say that no two electric field lines can cross each other, as at the point of intersection. So you can note down the answer as no two electric field lines can cross each other, as at the point of intersection there will be two directions of the field simultaneously, which is impossible. And as the last property, you can also write that electric fields, which we have already discussed, that electric field lines start from a positive charge and end at the negative charge, which you can also show by drawing. I hope you find this video helpful.
Please follow us on Instagram, Facebook, and Twitter at tribetopper.com.